Okay, so that function is actually odd. So I hope you managed to figure it out. Okay, so what is the next thing we need to do? So next thing I would like to do is review points of intersection of two graphs. Okay, so let's see. Okay, so points of intersection, let me make it, well, anyway. Okay, I'm struggling a little bit, as you can see. All right. Points of intersection. All right, so we have two graphs and they intersect at one or more points, and we'll try to figure out what those points are. Yeah, so this is example 4. And we have two functions. The first one is, let me just write what we need to do. So find points, point or points of intersection. Of two graphs. Okay, and the two functions we have are, first one is x squared minus x. Sorry, x squared minus y. Erase that. So x squared minus y equals 3. And the second one is x minus y equals 1. Okay, so yeah, we need to solve both of them for y. So if we solve this one, the first one we're going to get y equals x squared minus 3. And the second, if we solve this one for y, it'll be y equals x minus 1. Okay. All right, so what we'll do, we'll use the fact that if we have those points of intersection, y values for both of them and x values will be the same, right, for both of those functions. So we'll take and we'll make the y's equal. We could also make x is equal, but it will be more difficult, right, because we have x squared over here. Anyway, we just have a first power of y in both, so we'll make them equal. So let's just write y equals y. And then, yeah, we'll write those two functions. So x squared minus 3 equals x minus 1. And we'll just solve it for x. So I'll have x squared. So this is a quadratic function, right? So x squared minus x minus 2 equals 0. Yeah, so we're factoring it. We have AC, right, on the top, so negative 2, and negative 1 at the bottom. So two numbers that would multiply to negative 2 and add to negative 1. So that'd be negative 2 and 1. Right, so these are the two numbers that will go inside parentheses. So I have x minus 2 times x plus 1 equals 0. So now, right, again, we could use that zero product property. Well, let's just write x equals 2 or x equals -1. Right, so these numbers will make this whole expression equal to 0. Right, so yeah, so these are x's, right, of those 2 points of intersection, because we'll have 2. So now to find y, we can use any of the those two equations, two functions, but right, we'll use the simpler one, which is this one. So okay, so the first one, right, we'll have y equals, now I'm going to plug that -2 into the original function, x minus 1, so 2 minus 1. So y equals 1. And then the second one, right? So y equals, so -1 minus 1. So y equals -2. Okay, so let's write the answer. So points of intersection are, and so we have 2 points. So the first one is 2, 1, 2, 1, and the second one is -1, -2. Okay, yeah. So let's graph it and see. Maybe you can see what we actually did, right? So let's take. Let's see. Let's draw a coordinate system again, right? I'm trying to make those those lines straight. Right, I didn't succeed with this one. All right, I did with the x-axis. Okay, so yeah, we're just going to sketch it, right? So x squared minus 3 will be the first function, the first graph. So x squared minus 3 is a parabola with y-intercept 0, -3. So it'll be something like this. Whoops. Okay, let me try again. Okay, so that's a parabola. And yeah, so this was y equals x squared minus 3. Minus. And then the second graph, make it green maybe. The second graph was just a straight line, x minus 1. So, maybe I should fix it, right? It's just not crossing the y-axis at that -3. Maybe I could move it. I don't know how. Anyway, like this? No. Yeah, so let's just make this. How can we fix it? Let's see. You guys probably know. All right, so let's make this. Okay, let me try again. This is -3. Right there. Okay, we don't need that little thing. And let's graph the other one. So the other one is y equals x minus 1. So it's just right, like a 45-degree line that crosses the y-axis at -1. So again, it's going to be a bit of a struggle, right? And we have also 2 points, right? We could kind of try to make that line go through those points, right? So first of them was here, right? -1, -2, and the other one was 2, 1. Okay, well, it's not perfect, as you can see. Okay, let me try again. I don't like it. So I'll try again. Okay, I'll take that. Sounds good. So this one was y equals x minus 1, right? And that y-intercept is negative 1 right there. Okay. Yeah, so we have those 2 points of intersection. We could mark them. So that's the first one. This one was 2 negative 1, 2 positive 1, 2, 1. And then the other one was negative 1, negative 2. Comma negative 2. Okay. Yeah, so that basically is the right. We found those 2 points of intersection, and later on, I wonder if this works. Let me see. Later on, right, when we're actually doing calculus, we'll be finding the area of this. Well, the surface area of this region. Anyway, yeah. So for practice, can you guys do? Change the color here. So for practice, find points of intersection of these 2 lines. Unfortunately, these are very similar. Well, maybe that's a good thing. Okay, so we have the first line, first function. The second one is x squared plus y equals 6. Let's follow the same process, and you'll find those 2 points. And actually, yeah, let me give you the answer for this one as well. So those 2 points will be negative 1, 5. Right. So when you're taking notes of this, I'd like you to actually solve it. Right. So solve it showing work. Show work. Right. Finding